Welcome to STEM Education with Olufemi. I'm excited to have you join me on this mathematical journey where we make complex topics simple and engaging. My mission is to make STEM subjects accessible and enjoyable for everyone. Whether you're a student struggling with concepts or someone who wants to refresh their knowledge, this channel is for you. Today, we're diving into the fascinating world of polynomials. We'll explore what they are, how to multiply them, and how to divide them. By the end of this video, you'll have a solid understanding of polynomial operations. Polynomials are mathematical expressions that combine variables and constants using addition, subtraction, and multiplication. Watch as this polynomial forms before your eyes, showing the beauty of mathematical structure. So grab your notebook, get comfortable, and let's explore the wonderful world of polynomials together. Remember to like this video if you find it helpful, and subscribe for more STEM content. A polynomial is a mathematical expression that consists of variables and coefficients, combined using only addition, subtraction, multiplication, and non-negative integer exponents. Let's look at some examples of polynomials. Here we have 3x squared plus 2x minus 5. Each term has a different color to help you see the structure clearly. Here's another polynomial, x cubed minus 7. Notice it has a cubic term and a constant term. Even a single number like 8 is considered a polynomial. It's called a constant polynomial because it has no variables. Now let's see what makes an expression not a polynomial. These examples violate the rules we just learned. This expression has x to the negative 2 power. Negative exponents are not allowed in polynomials. This expression has x to the 1/2 power, which is a fractional exponent. Fractional exponents are also not allowed in polynomials. This expression has a variable inside a square root. Variables under radicals are not allowed in polynomials either. Remember, polynomials can only have variables with non-negative integer exponents like 0, 1, 2, 3, and so on. They can be added, subtracted, or multiplied, but cannot have negative exponents, fractional exponents, or variables under radicals. Every polynomial is made up of individual terms, and each term has specific components that we need to understand. Let's examine this polynomial and break down its anatomy. Let's start with the first term, 5x cubed. This term has 3 parts. The coefficient is the number 5, which tells us how many times we have x cubed. The variable is x, representing our unknown value. The exponent is 3, showing that x is raised to the 3rd power. Now let's look at the second term, 2x. Here, the coefficient is 2, the variable is still x, but notice there's no visible exponent. When no exponent is written, it's understood to be 1, meaning x to the 1st power. Finally, we have the constant term, negative 1. This term has a coefficient of negative 1, but no variable. We can think of this as negative 1 times x to the 0 power, since any number to the 0 power equals 1. Now that we understand the components of each term, let's talk about the degree of a polynomial. The degree is simply the highest exponent found in any term of the polynomial. Let's look at a few more examples to reinforce these concepts. Here we have 3 different polynomials with different degrees and term structures. Remember, coefficients are the numbers, variables are the letters, exponents are the powers, and the degree is the highest exponent. Understanding these components is essential for working with polynomials effectively. The distributive property is the key to multiplying polynomials. It tells us that each term in one polynomial must be multiplied by each term in the other polynomial. Let's start with a simple example, 2x times the quantity x plus 3. We need to distribute the 2x to both terms inside the parentheses. First, we multiply 2x times x, and then we multiply 2x times 3. 2x times x equals 2x squared, and 2x times 3 equals 6x. So our final answer is 2x squared plus 6x. Now let's multiply 2 binomials, x plus 2 times x plus 3. We'll use the FOIL method, which stands for first, outer, inner, last. First, we multiply the first terms, x times x equals x squared. Outer, we multiply the outer terms, x times 3 equals 3x. Inner, we multiply the inner terms, 2 times x equals 2x. Last, we multiply the last terms, 2 times 3 equals 6. Now we combine all terms, x squared plus 3x plus 2x plus 6. We can combine the like terms 3x and 2x to get 5x. So our final answer is x squared plus 5x plus 6. Remember, the distributive property ensures that every term in one polynomial multiplies every term in the other polynomial. This is the foundation for all polynomial multiplication. Now we'll tackle a more complex polynomial multiplication problem that involves a binomial times a trinomial. Here we need to multiply the binomial 2x minus 1 by the trinomial x squared plus 3x minus 2. Step 1. We need to distribute each term in the first polynomial to each term in the second polynomial. First, we multiply 2x by each term in the second polynomial, x squared, 3x, and negative 2. Then we multiply negative 1 by each term in the second polynomial. Step 2. Let's simplify each multiplication. 2x times x squared gives us 2x cubed. 2x times 3x gives us 6x squared. 2x times negative 2 gives us negative 4x. From the second distribution, negative 1 times x squared gives negative x squared. Negative 1 times 3x gives negative 3x. Negative 1 times negative 2 gives positive 2. Step 3. Now we combine all terms together. We have 2x cubed plus 6x squared minus 4x minus x squared minus 3x plus 2. We identify like terms. We have one x cubed term. For x squared terms, we have 6x squared minus x squared, which equals 5x squared. For x terms, we have negative 4x minus 3x, which equals negative 7x. And we have the constant term positive 2. Our final answer is 2x cubed plus 5x squared minus 7x plus 2. Notice how we carefully track the signs throughout the process and combine like terms systematically. The key to success with complex polynomial multiplication is careful attention to signs and systematic organization of like terms. Polynomial long division works just like the numerical long division you learned in elementary school. We'll divide polynomials step by step using the same process. Let's work through the example. X squared plus 5x plus 6 divided by x plus 2. We'll set this up in long division format. Step 1. We divide the first term of the dividend x squared by the first term of the divisor x. This gives us x. Step 2. We multiply x by the entire divisor x plus 2, which gives us x squared plus 2x. Step 3. We subtract x squared plus 2x from the dividend. This gives us 3x plus 6. Step 4. Now we divide 3x by x, which gives us 3. We add this to our quotient. Step 5. We multiply 3 by x plus 2, giving us 3x plus 6. Step 6. We subtract 3x plus 6 from our remainder, which gives us 0. This means our division is complete. Therefore, x squared plus 5x plus 6 divided by x plus 2 equals x plus 3. Let's verify this by multiplying our answer back. To verify, x plus 3 times x plus 2 equals x squared plus 2x plus 3x plus 6, which simplifies to x squared plus 5x plus 6. This matches our original dividend, confirming our answer is correct. Polynomial long division follows the same pattern: divide, multiply, subtract, and bring down. With practice, this becomes a powerful tool for simplifying complex polynomial expressions. Synthetic division is a powerful shortcut method for dividing polynomials by linear factors of the form x minus a. It's much faster than long division and produces the same results. Let's use the same example from our long division section. We want to divide x squared plus 5x plus 6 by x plus 2. For synthetic division, we first need to identify the value of a. Since we're dividing by x plus 2, we rewrite this as x minus negative 2. So a equals negative 2. Next, we write down the coefficients of the dividend polynomial. For x squared plus 5x plus 6, the coefficients are 1, 5, and 6. Now let's set up the synthetic division table. We place negative 2 on the left and the coefficients 1, 5, 6 across the top. Step 1. Bring down the leading coefficient. The first coefficient, 1, comes straight down to the bottom row. Step 2. Multiply the value we just brought down by a, which is negative 2. 1 times negative 2 equals negative 2. Write this under the next coefficient. Step 3. Add the values in the second column. 5 plus negative 2 equals 3. Write this in the bottom row. Step 4. Multiply this new value by a again. 3 times negative 2 equals negative 6. Write this under the last coefficient. Step 5. Add the values in the last column. 6 plus negative 6 equals 0. This is our remainder. The bottom row gives us our answer. The last number, 0, is the remainder. The other numbers, 1 and 3, are the coefficients of our quotient polynomial. So our final answer is x plus 3 with remainder 0. This means x squared plus 5x plus 6 divided by x plus 2 equals x plus 3 exactly. This is exactly the same result we got from long division. Synthetic division is much faster and requires fewer steps, making it the preferred method when dividing by linear factors. We've covered a lot of ground in our polynomial journey today. Let's quickly review the key concepts we explored together. First, we learned what polynomials are: mathematical expressions made up of variables, coefficients, and exponents, combined using addition and subtraction. Next, we mastered polynomial multiplication using the distributive property, learning to multiply each term in one polynomial by every term in another. Finally, we explored polynomial division through both long division and synthetic division methods, giving you powerful tools for simplifying complex polynomial expressions. Thank you so much for joining me on this mathematical adventure. I hope these concepts will help you tackle polynomial problems with confidence. If this video helped you understand polynomials better, please give it a thumbs up. Your likes help more students discover these important mathematical concepts. Don't forget to subscribe to STEM Education with Olufemi for more engaging mathematics and science content. Hit that subscribe button and the notification bell so you never miss a new lesson. I'd love to hear from you in the comments. Let me know which polynomial concept you found most interesting, or suggest topics you'd like me to cover in future videos. Keep exploring, keep learning, and remember, mathematics is everywhere around us. Until next time, this is STEM Education with Olufemi, signing off.